Assalamu alaikum everyone. Today's video is on congruent triangles. This is a tricky topic, and it's a topic I like to say helps students use maths to become into future lawyers. The reason for this is for every point we make, we need to have some evidence, and there is a structure that is required to give you a proof. It's not necessary to give you proof in that particular way, but we shall see. It just makes it a bit easier. So we're going to be looking at a few rules in this video, and there's going to be a question for each rule. Some rules have a stipulation with them, and some rules do not. So let's get started. The first rule we're going to use is by far the easiest rule to prove congruence. It has no stipulations whatsoever. You just have to prove that three sides in one triangle are equal to three sides in the other. This rule is called the SSS rule. We have a question. ABCD is a rectangle. Prove that triangle ABC is congruent to triangle ADC. So in order to answer this question, as I told you, this topic helps you become a lawyer. I'm going to start off with an opening statement, and the opening statement is in triangle ABC and triangle ADC. Now let me highlight the two triangles. So this is triangle ABC and this is triangle ADC, and we know that ABCD is a rectangle. So I'm going to start off. AB, that's this side over here, is equal to CD, that's this side over here. Now I've made a point, but I haven't given any evidence for it, so I have to use a property to give some evidence for it, and the property I'm using is opposite sides of a rectangle are equal. Now my second reason is gonna be, well, second point, is BC is equal to, let me reverse that, AD is equal to BC. Now AD is this side over here and BC is this side over here. Again, the reason is the same, so I'm not going to rewrite it. I'm just going to put a little bracket kind of thing to point out that both of these points have the same reason, that is opposite sides of a rectangle are equal. Now that's the one side, that's the second side. If I'm going to use the side rule, I need to use a third side. The third side that remains is the side AC. And if you look at the side AC, it is shared by both triangles. In triangle ABC, you have the side AC, and in triangle ADC, you have the side AC. So since they both share the same side, we can say this is a common side. So those are my 3 points, and I've given the reasons for them. Now I have to write a closing statement. Therefore, triangle ABC is congruent to triangle ADC That's not enough. I have to write down the rule which I have used to prove the congruence. So the triple S, side, side, side. And that's how I would lay out an answer to this particular question. Now congruent, the word congruent means exactly the same, like a clone. So when you're using the SSS rule to prove congruence, what I'm trying to say is this triangle ABC is exactly the same as the triangle ADC, and the rule I've used is the SSS rule, in this case the three sides. There are more rules. Let's look at the next one. In this case we're going to be using the SAS rule, the side angle side rule. But before we use this rule, there is a stipulation to this rule. And the stipulation is this angle has to be an included angle. Now for those of you not sure about what an included angle is, it's an angle made by the two sides which we're going to use. So we're going to use this side and this, sorry about that, I'm going to use this side and this side, and those two sides will meet at a point to make an angle, and that's called an included angle. So the two sides which we use to prove the congruence will meet at a point, and the angle they form is going to be the included angle, and we have to use that. If you do not have an included angle, you cannot use the SAS rule. Let's look at the question. ABCD is a rhombus. Now rhombus is a quadrilateral with 4 equal sides. Okay, M and N are points on the line BD. So this is the line BD here, and we have M and N on BD such that DN, or DN here, is equal to MB. So I can make a mark on the diagram showing that this is equal to this. Prove that triangle DNC is congruent to triangle BMC. So before I even get started, I'm gonna just make some markings on the diagram. Since ABCD is a rhombus, all 4 sides are equal to each other. Now if you notice, right, the question's asking us to prove that DNC, which is this triangle, is equal to BMC, which is this triangle. But if, however, I highlight this red triangle here, this is an isosceles triangle, since DC is equal to BC. So you have this angle equal to this angle, because they are base angles of an isosceles triangle, and base angles of an isosceles triangle are equal. But the question is asking us to prove the two yellow triangles are equal. So this one, let me use a different color, the two blue triangles. So this one and this one. So we're going to get started in the same way. We first start off with our opening statement. So in triangle DNC, and triangle BMC, okay, I'm gonna say this side DC, which is this side here, is equal to BC, which is this side over here. And the reason for that is all sides of a rhombus are equal. Okay, now the next reason I'm going to give is dn is equal to mb. And in this case, that's given to me in the question over here. So I'm just going to write the word given. I don't need a property for that because the question's given me that information. Now remember when I told you earlier on, if I use the SAS rule, the two sides I use meet at a point. So I've used DC, which is this side, and DN in triangle DNC, which meet at that point, forming the angle NDC, and that means that NDC is the included angle. And I've used BC, which is this side, and MB, which is this side, and those two sides meet at the point B, forming the included angle MBC. So in order to prove congruence using this particular rule, I have to use the included angle. So angle NDC is equal to angle MBC. And the reason for this, if we remember earlier on the red triangle which we were looking at, and let me just show that red triangle again to you. Just gonna go over this red triangle. You can see that this red triangle here is an isosceles triangle because BC is equal to DC, right? Because they're sides of a rhombus and all sides of a rhombus are equal. So the reason for this is base angles. Let me just correct that. Just had a situation there. Base angles of an isosceles triangle are equal. Right. So now I'm going to write down my closing statement. Therefore, triangle DNC is congruent. Now this little symbol here means congruent. I didn't explain that in the previous question, so I'm explaining that now. So it's an equal sign with a wiggly sign on top, wiggly bit on top. Triangle BMC. And that's not sufficient. I have to write the rule I've used, SAS. There we go. Okay, so we've looked at the SSS rule, no stipulation. SAS rule, the angle has to be an included angle. That was the stipulation in that one. And the next rule we're going to be looking at is the angle side angle rule. This comes also with the stipulation, and the stipulation here is the placement, sorry, not the placement, placement is not such a good word, position of the sides and the angles need to be the same. In both the triangles. What I mean by this is, in this particular case, I'll explain that in this question. So let's look at the question first. So ABCD is a parallelogram, and before we get started on the question, I can make some markings. In a parallelogram, opposite sides are equal. So AD will be equal to BC, and AB will be equal to DC. Okay. E is the point where the diagonals meet, which is over here in the middle. Prove that triangle ABE is congruent to triangle CDE. So let's mark our two triangles in red. ABE is over here. ABE, that's that triangle, is congruent to triangle CDE, which is this one. So when I'm talking about the positions, I have to be sort of very careful of the location of the sides and the two angles I've used. So suppose if I use this angle here and this angle here, both of them have to be located opposite that side. You see, if I use this angle here, it has to be made by this side and this side, and then that would have to be equal to this angle here made by this side and that side. So the location or the position of the angles and the sides makes a huge difference in this. I can't say that this angle will be equal to this angle, because this side will not necessarily be equal to that side there. Okay, so that's what we need to be wary about. And let's get started on this particular question. So we start off with our opening statement. In triangle ABE and triangle DEC. Okay, so let's start off with the information I have. I know AB is equal to DC or CD, and the reason for this is opposite sides of a parallelogram are equal. Okay, now I'm going to use this angle here, and I'm going to say that's equal to that angle there, because they are vertically opposite angles, and vertically opposite angles are equal. So angle AEB is equal to angle CED or DEC. The reason for that is vertically opposite angles. My pen just stopped writing there. Let's try that again. Are equal. Okay, and then the third one I'm going to use is this angle here. Okay, now the reason I'm using this angle here is in a parallelogram, opposite sides are parallel as well. So that means AB is parallel to CD. So if I was to follow ABE and then carry on with EDC, it makes a Z shape, right? So these two angles, because these two sides are parallel, okay, then that you got that Z shape over there, and these two angles are in between. BD forms a transversal, so they're both internal angles and they form a Z shape, so that means they are alternate angles, so therefore they are equal. Angle ABE is equal to angle EDC and the reason for that is alternate angles are equal. therefore triangle ABE, this is my closing statement, is congruent to triangle DEC. That's not sufficient. I need to write down the rule I've used, ASA. Again, I have written down all the reasons for all the points I have made, and then I've used the rule in this question. There's one more rule which we need to learn, and that is the RHS rule, right angle hypotenuse side. So let's have a look. Again, we'll do a question to demonstrate how we can use this rule. So let's see, ABCD is a square. Prove that triangle ABD, which is this one, triangle ABD, is congruent to triangle BCD. Okay, so I'm going to start off, since ABCD is a square, just make some markings. All sides of a square are equal and all angles are 90 degrees, so that's 90, that's 90 as well. Okay, now you can do this question in a different way as well, but I'm gonna do it in this particular way in order to demonstrate the RHS rule. So let's start off with our opening statement as always. In triangle ABD and triangle BCD, so in triangle ABD and a triangle BCD. Okay, let's start off. I can say the right angle first. So angle BAD, bad. Angle BAD is equal to angle BCD is equal to 90 degrees, and I can write the reason. All angles in a square are 90 degrees. That's my reason. Okay, the second one is the hypotenuse. So the hypotenuse is the longest side, which is BD. So BD is shared by both triangles, so it's a common side. BD equals BD, and the reason is it's a common side. That's sufficient. The last one is a side. I can choose any, but again, the location and the position needs to be important in the correct place. So AB and this triangle is equal to CD over there. That's what I'm saying, and the reason for that is all sides in a square are equal. Okay, so I've made my 3 points. I've given my evidence in terms of the properties. Now I write my closing statement. Therefore, triangle ABD is congruent to triangle BCD. And the reason for that is I've used the RHS rule. I've got another question just to practice, and hopefully we'll get some time to do some more videos on questions only on congruent triangles. So this is an interesting question. It says in the diagram over here, ADE, where's ADO? There we go. ADE is a right angle triangle. ABCD, that's this one here, ABCD is a square, and AEFG, that's an awkward name, AEFG is another square. Okay, it's saying prove that triangle ABE Which one's triangle ABE? Let's see. Triangle ABE, I'm gonna draw this one in red. Let me try and get more accurate. Oops, just dropped my calculator. A, B, E. That triangle is congruent to triangle ADG. So I'm going to do that in green. Sorry, blue. ADG is there. Okay, that's fine. Let's look at, before I get started, I need to try and figure out some information. Let's use green. You see, AB and AD have to be the same because they're both sides of the square ABCD, and similarly AG and EA are both sides of the second square, which is AEFG. Right. Now here's an interesting thing. We know all the angles in a square are 90 degrees, so that has to be 90. So does that, right? So if I was to call this particular angle here X, angle EAB would be 90. Angle EAB would be 90 plus X, and angle DAG would also be 90 plus X. And guess what? AD and AG are the two sides we're using in the blue triangle, and AB and AE are the two sides we're using in the in the red triangle. So this 90 plus X and this 90 plus X, they're going to be included angles, so we can use the SAS rule. So let's get started in this particular question, right? Our opening statement: in triangle ABE and triangle ADG, AB is equal to AD, and that's AB here is equal to AD, and the reason for that is all sides of a square are equal. And I can also say AG is equal to, AB was red, let me say AE then. AE is equal to AG. So that's AE is equal to AG. Again, it's the same reason, so I'm just gonna put a bracket for both of them so I don't have to write down the reason twice. And then the last one is angle EAB is equal to angle GAD is equal to 90 plus X. I don't need to write a reason for that, that is my reason. That's EAD, so it's the 90 degree angle here plus the X. Let me show that to you in red on the diagram. It would be this, so it's 90 plus X. and the second one was GAD. So I'm going to show you that to you in blue in the diagram. So it's going to be this angle here, which is, let's try that again, this angle here, which is this 90-degree angle plus the x, so that'll be 90 plus x. So let's close this particular question off with a closing statement. Therefore, triangle ABE is congruent to triangle ADG. And what rule did we use? We used a side, another side, and an included angle. So that's an SAS rule. And there we go. We have proven congruence. Okay, that's all for this particular video. I will try and see if I can do future videos on this topic as well, but I do hope that this particular video has helped you in your learning. Stay safe and thanks for watching. Take care.